We will begin this module by explaining the basic concept of the fly-by-wire system. In conventional aircraft, the movement of the control column is transferred along cables and pulleys until it reaches the control surface to be moved. In the A320 family, the cables and pulleys have been replaced by electrical wires. This has the advantage of saving weight on the aircraft. However, there are even greater advantages, as the video clip will demonstrate. Click on the video window to start it.
Now the way became clear to reassess the mechanical linkages, transferring the control commands to the electrically actuated hydraulic motors that work the flying surfaces. As electrical signals were already being used to control the motors, the logical step now was to send the message to them direct from the control column by electrical wire, resulting in a far simpler and lighter system. And without the need to exert muscle power, the conventional control yokes could be replaced by small side sticks.
The electrical signals created by side-stick movement travel through flight control computers before being passed to the surface hydraulic actuators, also named servo controls. These computers analyze the signal to check that it is a safe command and ensure the optimum flight control surface deflection for the demand. This has advantages over conventional systems. It makes the aircraft extremely stable, enhances safety, reduces the workload of the pilot. Let's now look at the flight control surfaces themselves. The flight control system incorporates ailerons, elevators, a trimmable horizontal stabilizer, THS, for pitch trim, a rudder, ground spoilers, speed brakes. Now let's introduce the ECAM flight control page. You can see that all the flight control surfaces we have talked about are displayed. We will now see them in more detail. The movements of both ailerons and both elevators are symbolized by a green index moving in front of a white scale. The green rudder symbol is used as an index to display the movements of the rudder on a white scale. The rudder trim is indicated by a small blue line below the scale. Note that the rudder and the pedal deflections are limited as a function of speed via a rudder travel limiter. The rudder travel limit is indicated by small white ticks. It is presently in the high speed position. The pitch trim position is indicated by trimmable horizontal stabilizer deflection in degrees up or down. Let's continue with the spoilers. The spoilers have several functions. Speed brakes use the 3 central surfaces. Control uses the 4 outer surfaces. On the video, look at the left spoilers as they deploy, then at the right ones as the wings are leveled. Click on the video window to start it. Ground spoilers use all surfaces. On the video, watch as all the spoilers deploy at touchdown. Click on the video window to start it. On the ECAM flight control page, the spoiler extended position is indicated by small arrows. This is the case of the speed brakes. All these control surface indications will be explained in more detail in the normal and abnormal operation modules. Now we will look at the flight control computers. The movements of the flight control surfaces are managed by 7 computers. These are 2 elevator and aileron computers, ELAC, 3 spoiler and elevator computers, SEC, 2 flight augmentation computers, FAC. In addition, 2 flight control data concentrator computers, FCDC, are used to acquire data from the ELAC and SEC. Then they send it to the EIS. However, the data from both FACs is sent directly to the EIS. The status of ELAC and SEC is indicated on the ECAM flight control page. The other computers are not displayed. These indications will be seen in more detail in the abnormal operation module. Now we will see the hydraulic aspect. 3 independent hydraulic systems are used to power all the flight control surfaces. The hydraulic systems which actuate each control surface are indicated on the ECAM flight control page by the use of G, B, and Y. For example, the rudder is powered by the green, blue, and yellow hydraulic systems. The ECAM flight control page is now complete. Pilots control pitch and roll through 2 side sticks. There are associated side stick priority lights. Side sticks and priority lights will be explained in a separate module. Pitch trim wheels are located on the center pedestal. There are 2 sets of conventional rudder pedals. A rudder trim panel is located on the pedestal. A speed brake lever is located on the left side of the pedestal. In addition, there are 2 panels located on the overhead panel to control the flight control computers. Now we will introduce the lift augmentation devices. There are 5 slats on each leading edge and 2 flaps on each trailing edge. The slats and flaps are hydraulically actuated like all the other surfaces. They are electrically controlled via 2 slat flap control computers, SFCC. Each SFCC has 2 channels, one for the flaps and one for the slats. Each channel can drive its associated surfaces. The flap lever located on the right side of the pedestal operates the slats and flaps. The flap lever has the following positions: 0, 1, 2, 3, and 4. The flaps and slats information is shown on the engine warning display. The flap and slat positions are indicated by white dots. Here the surfaces are extended to position 1 plus F. This is the flap 0 indication. Notice there is no labeling with this setting. The slats and flaps are fitted with protection functions. In particular, surface asymmetry between left and right wing, surface attachment failure, overspeed or uncommanded movement are detected. All these protections will be seen in detail in the abnormal operation modules.